Today our topic is your logic gate, and in this video we will try to clarify the three basic logic gates: AND gate, OR gate and NOT gate. NOT gate is also known as inverter gate. So one by one, at first we will take AND gate, design of AND gate, we will see the circuit of AND gate and how to make the truth table of AND gate. So let's see, first is your AND gate. AND gate. In AND gate, how the designs looks, or it is what AND gate D, so write a D here, write a D here, and there are two inputs, this is your A, and let me tell you, say it is your B. There is only one output, say this is your Y, and output is given by Y equals to A and B, or you can simply say A into B. This is your AND gate. Now, second part, we are going to see the truth table of AND gate. Before that, let me give an example. If I consider two statements, my first statement is 5 is greater than 3. My second statement is 2 is greater than 5. Definitely second statement false. Now if I say 5 is greater than 3 and 2 is greater than 5, my statement is false. What does it mean? A compound statement is true if both the component statements are true. So in this case also, similar arguments we are going to use. And here, true and false we are not going to use, 1 and 0. And in electronic devices, 1 means high and 0 means low. Or you can say 1 means switch is on and 0 means switch is off. So see, it is your A, it is your B, and Y means A and B. This is the fact. Y and B. So now one question may come to your mind, that how many rows will be there? How many inputs I had given? 2 inputs. So 2 square equal to 4. 4 rows will be there. If there are one more input, say C, then 2 cube equal to 8 number of inputs will be there. Okay. So at first, let me consider the 2 inputs are there, and here binary digits we are going to use 1 and 0. So how to write the rows? The rows can be written very easily. Simple technique I am saying, write 1, 1, 0, 0. The thought process is this: 1, 1, 0, 0. After that, alternately 1, 0, 1, 0. So all the possible combinations we have got. Now you see, as I told, a compound statement is true if both the component statements are true. In all other cases, compound statements are false. Simply 1 means high. This is 1 high. Both are high. Then A and B, this is also high. And in all other cases, it will be low, low, low. And it will take 0, 0, 0. This is the fact. Now this is the truth table for your AND gate. Now let me give example of a circuit for truth table for this AND gate. See this circuit, how the circuit looks like. It is like this. Say here is the battery, here is your battery. Now there are 2 keys. Let me give one key here and another key is here. It is like this. This is your A and you can say this is your B. And some bulb, let me connect here. Some bulb is here. Now you see, if switch A is in 1, or you can say it is on, tapping key, and if it is on, Then will the bulb glow? Definitely current will not go to the bulb, so it will not glow. Next, suppose B is in a high, or this switch is on. On means 1. Then will the bulb glow? Definitely not. So the bulb will glow only when both the keys are closed. Both the keys are closed. Only under this case, current will flow to the bulb. This is the fact. That was the example of AND gate. Circuit you have seen. How to make the truth table you have seen. And what's the design of AND gate? The technique I have to. AND having D, take D here, 2 inputs, 1 out. That's it. Now, let us take OR gate. Now we are going to take the OR gate. And truth table for OR gate and one circuit we will see for OR gate. Say here OR gate. See, OR gate O is here. OR gate or O ase. So to me, correctly, you do one thing, write a O like this way, then rough one part of this O and put it like this way. Means half of the O you have drawn. And there are also two inputs. Input A, input B, only one output Y, which is equals to, as it is OR gate, in set theory also, OR means plus, so you can denote it A plus B. Now you see, truth table for OR gate. A, B, Y equal to A plus B. So, the truth table for OR gate we are going to write. For this, again let me give some example. If I say 3 is a prime number or sun rises in the west, my statement is true. If I say sun rises in the east or 3 greater than 7, then also my compound statement is true. If I say 3 greater than 5 or sun rises in the west, only in that case my statement is false. What does it mean? If both the component statements are false, then compound statement is false. Similar thing here, if both A and B are low, that is 0, A is also 0, B is also taking 0. In that case only A or B or a Y output will be 0. It is like this. At first let me make the rows. How to make the rows? Similar process. 1, 1, 0, 0. 4 number of rows will come. Then 1, 0, 1, 0. You have got it. Now you see. Only in one case this will be low. That means both the switches are off. In that case only current will not flow. You can say it is 0, it is low, it is also low. In that case it is 0. In all other cases the value will be, truth value will be 1. 1, 1, 1. So this is the truth table for your OR gate. Now it will be more clarified. We can clarify this by taking some example of circuit. So for OR gate, let me take an example of a circuit. So for this, the circuit look like this, you see. Here is the battery and here let me connect some bulb. Some bulb is connected here in the circuit. Now, here is a switch and here is also a switch. It is the circuit for OR gate. OR gate. So we have done circuit for OR gate also. Design of OR gate you have learned. Truth table of OR gate it is clear. And now you see, when this is suppose A, this is B. Say A1, A is 1 means switch is closed. Switch it is closed. And it is B is in 0. That means it is open. In that case, current will definitely flow like this way. The current will flow this path. and the bulb will glow. Now, say this is your in zero mode and B is in your high mode. That means it is closed now. It is closed. In that case also current will flow, and this path will current will flow this path, and bulb will glow. So from the circuit it's very much clear to you. If both are in zero mode, that means both the switches are off or low. In that case, current will not flow to the bulb and the bulb will not glow. So this is the circuit for OR gate. This is the design of OR gate. This is your truth table of OR gate. I hope these two gates are clear. Now, the most interesting, that is your NOT gate or your inverter gate. So let us take that one now. See, in case of NOT gate, now it is your NOT gate. The design look like this. It's little bit interesting also, and only one output is there. In NOT gate, only one input is there, and definitely here is a ring. Here is a ring you have to make, and this is output Y. And how it works? Suppose input is A, then output is Y equals to A complement or A bar. It is like this. If suppose A1 input is high, then in this case A bar it will be 0. When A takes the value 0, low, then output is your 1. You can say when switch is on, bulb will not glow. When switch is off, bulb will glow. And you have seen this at your home. If you observe your fridge, when the fridge, you open the fridge, then you will see light or bulb will glow inside the fridge. As soon as you will close the fridge, that means in the fridge there is a switch, and when you will close it, that is switch is on. That means you are pressing the switch. So it is high mode and the bulb will not glow. Inside the fridge it is dark. As soon as you open the fridge, that means the switch is released. It is off and the bulb inside the fridge it glows. So this is the function of your circuit, your NOT gate. This is the fact. And see the circuit of NOT gate. How the circuit look like for NOT gate. It is like this. Say here is the source or battery, and it comes like this way. Here is a tapping key. Here is a tapping key. And let me connect a bulb here. Here is a bulb. Now you see. When it is in zero mode, now it is in zero mode, that is low. Switch is off. Current will flow in this direction and bulb will glow. As soon as you will tap the key, then it is closed. And as you know, current always follow the shortcut. So in that case, what happens? Current will flow like this way. Current will flow. Current will not go to the bulb. Current will follow the shortcut. Current will, and it will back to the battery. So this is the circuit for your NOT gate. So three basic gates we have discussed: AND gate, OR gate, NOT gate or inverter gate. Remember, this is also known as inverter gate. In next video, I will generalize the case. Say it is your where two inputs you have considered. In case of AND gate, you will consider 3, 4, 5 inputs, and then how the outputs coming out. And after that, the universal gates also will be discussed.